our first question is, let's see. We have got, now you've got to listen carefully because I'm not going to write all of this out. It says the first cloned animal in Africa is a calf called Futi, all right? And he was born in a northwest province in South Africa on the 19th of April 2003. No fertilization was involved in the production of Futi. She was produced from a single cell taken from the ear of donor cow. So let me put here. Okay, so we have, let's just quickly do this. The donor cow. And the donor cow is named, so this would theoretically be the mom, but this is the donor cow is LMJC865. Okay, and we then got an ear cell. All right, and then it says here, this donor cow had an average milk yield of 78 liters per day, which is a huge amount. Now, cloning allows for the production of organisms with desired characteristics, okay? So, what would the desired characteristic be? That it would be the 78 liters of milk per day. So this now is our desired characteristic. And remember, I've said to you, you can always use the word trait instead of characteristic. It's so much easier to write and quicker to write and easier to spell as well. Okay, then it says some people argue that cloning reduces genetic variation, which it does. In the offspring, there's no further genetic development because evolution can't take place because you've got no gametes being formed, you've got no random assortment, and you have no crossing over during meiosis or during prophase 1, none of that. Okay, so there's no further genetic improvement. Cloning is expensive and it may not be economical, all right, because it is so expensive. Okay, then it says, according to the extract, state one advantage of cloning and one disadvantage of cloning. Well, they actually give it to you in the extract. So one advantage would be that you can, the cow with the desired characteristic of 78 liters of milk per day can then be produced. And the disadvantage, there are lots. The disadvantage is that the scientists are playing God, that you can end up with scientists producing something in a lab. It's like genetic modification. This is genetic modification. That's what cloning is. So they could go and produce, they could take HIV and they could take SARS virus, COVID-1, and they could put the two together and they could produce something like, well, the SARS CoV-2 that is hitting us all across the world now. So that is what makes it a bit of a problem with disadvantages of cloning. But also, apart from the fact in this extract, they then say that there's no variation, there's no further genetic improvement, it's very expensive. So you could have taken all of that from the extract. But just think about what cloning and genetically modified crops and genetically engineering anything, what the advantages and the disadvantages are, because if they ask you a question like this, they will ask that. Then it says, state why the donor cell was taken from this cow, LMJC865, and not from any other cow. Well, because she had the desired characteristic of producing 78 liters of milk a day. And then state why an ear cell was used and not an ovum, and then describe the process of cloning. Now, just before we carry on, that question we got from Nicole Tenodashi, okay? And then we got a very similar question from Noria about Dolly. And Dolly was the sheep that was cloned in 1997, I think. And here again, let me just go through what cloning is, and you need to understand that. When we normally have, so it's for both of you, all of this applies. And learners, please make sure that you know this kind of thing. All right, so we go back to Nicole's question, where it says, describe the process of cloning. Why an ear cell was used and not an ovum. Now look at this. In order to produce a gamete. So an ovum is a gamete. Oh, and there's my joke has just come up on the screen. But anyway, guys, okay, let's look at our joke of the day. We have, hey, half my chromosomes are yours, you know. So there we go, and I'm not sure what's going on here, but anyway, okay, so an ovum is a gamete, okay? How are gametes produced? They're produced by a process of meiosis. Now, during meiosis, we have a diploid cell. Now, that diploid cell is 2N because it has 2 sets of chromosomes. Okay, 2. One set is from the father of that organism, and one set is from the mother. Okay, so it'll look like this. And these are what will make up our homologous chromosomes. Okay, now when meiosis takes place, we have prophase, metaphase, anaphase, telophase 1, and then we have prophase, metaphase, anaphase, telophase 2. And at the end of all of that, we are going to now go from this diploid cell is going to have reduction division during meiosis. Okay, meiosis 1. And I now sit with one set of chromosomes. Okay, here's one set and here's one set. Now, we then have meiosis 2, and during meiosis 2, this is what's going to happen. So we now have haploid, haploid, haploid. These 4 are all genetically unidentical. Okay, and we have 4 little gametes that result, and they are genetically unidentical. All right, now that would end up making a gamete. So in a female, one of these will become an egg cell, any one of those, and 3 become the polar bodies. And in the male, we have 4 sperm cells. And that's in your male. And in the female, we have 1 ovum plus 3 polar cells. And that's the female. Okay, so here is my ovum. My ovum is going to be a gamete, and it is going to be haploid. What did they do here? They took from this cow, this donor cow, okay, they took an ear cell. Now, that ear cell is a somatic cell. And somatic cells are all diploid. During fertilization, we are going to have 1 sperm, which is haploid, plus an ovum, which is haploid, and that is going to give us a diploid zygote. Okay, so it's going to be 2N. But here we're not going to use fertilization. So what happens with that question from Dolly the sheep, and here, they take an ear cell. Oh man, what am I doing? Ear cell, which is already diploid. Okay, and then they take that and they insert into an ovum. Okay, but that ovum clearly has to be empty. It's got to be open. It's got to have nothing inside it. They've got to remove the nucleus, because otherwise you're going to end up with something that is triploid, which is going to be a mess. So in order to answer the question, that last question, let me just clear my screen here. This is how we are going to do it. So they want us to explain the process of cloning. And remember, cloning is one form of genetic engineering. All right, so the first thing that you're going to have to say is that, 1, the nucleus of an ovum is removed. So now that little ovum is empty. Okay, that's number 1. The next thing that's going to be really important is that the nucleus of a somatic cell, in this case it was an ear cell, of a somatic cell is going to be removed and inserted into a ovum or the ovum cell. All right, and once it's inserted into that ovum cell is now, which will now be diploid and not haploid, because remember here it was haploid or N. Here it's going to be diploid or 2N. All right, so there are your steps. You have a nucleus of the ovum is removed, and then you have the nucleus of a somatic cell is removed, and that nucleus is put into the ovum. In other words, there's been no reproduction. There hasn't been a male gamete and a female gamete, or a sperm cell and an egg cell ovum that have now combined to form a diploid zygote. You've taken a diploid cell, which means that the donor of that diploid cell, that diploid somatic cell, okay, and the offspring is going to be identical. So if I took one of your diploid cells and I took that nucleus and I put it into an ovum and then allowed that to grow in another uterus, you are going to be identical. Not even like twins, you're going to be identical. All right, so now, we've now done the inserted into the ovum. Okay, so what happens now? The fourth point is that the zygote is stimulated by mitosis, okay? Is stimulated, no, what am I doing here? And mitosis occurs. All right, because remember now it's still sitting in the fallopian tubes. All right, and then, or it would be if it was natural, then the zygote is implanted into a receptive uterus. Okay, so everything that would have happened in the fallopian tubes under normal circumstances is done in a lab in a test tube. Okay, and that is then that little zygote, when it gets to blastocyst size, gets taken and it gets implanted into a receptive uterus. And there you go. Perfect duplicate of you. Okay, so girls, I hope that you both are happy with the way we've answered this question. And just remember your advantages and your disadvantages of cloning, of any kind of genetic engineering. And very often, if they ask a question on cloning, they are going to ask advantages and disadvantages. All right.